Kia ora, Year 11 and 12. This is another question from assignment 3 that you've done if you're in my A-level class this year. But if you're watching this and you're doing level 3 calc, I think it's still a good question. It's probably slightly harder than what you're used to, but I think it's covered by the curriculum and is examinable for complex numbers. So it's all about a polynomial and what it's divisible by. So here's the question done up a bit bigger. We're given a polynomial which is this. It's 4x to the power of 4 plus something x squared plus 11x plus something. And so you can guess that we're going to have to work out what the a and b are. And we're told that p of x is divisible by this. Now, if this were just a linear factor, for example, x minus 3, this would be easy because we could use the factor theorem. So suppose instead it said it's divisible by x minus 3. Then what we'd do is we'd substitute in p of 3 and we'd say, well, we know that that equals 0 by the factor theorem. But we can't do that because we don't have a linear factor, and the factor theorem works with linear factors. So you might think, oh, but hang on, maybe I can factorize x squared minus x plus 2, because if I can turn that into two linear factors, then I've got two opportunities to use the factor theorem. But I can't do that. If you try to factorize this thing here, you'll find that it won't factorize easily. It's got no real roots. So instead, we have to use brute force to find the values of a and b. Now, there are two ways to do this. You can either do it by matching up the coefficients, which is my favorite method, or you can do it by long division. Most of you tried to do matching up. A few of you did successfully do that, and some of you tried long division. I'm going to do both ways in this video. So let's see what we can say about p of x. Well, we can start by writing it down. So p of x is equal to this. And we know, because x squared minus x plus 2 is a factor, that we can write this. So this is the first factor. And now we're going to have the other bit that's going to multiply to give me this. So I've got an x squared here, and I need to get 4x to the power of 4. So straight away I can say that first term must be 4x squared. Sometimes, if I'm given the value for the constant, I can do this number at the end here. But I haven't got that luxury today. So what I'm going to do instead is write this, plus mx plus n. So what I'm using here is the idea that if this is a polynomial of order or degree 4, then if we know that this is a quadratic, then this thing must be a quadratic as well. So my strategy is now to use what we know over here to figure out m and n over here. So have a look here and decide what you're going to match on first. Well, the way I did it is I said that there's no x cubed term. So let's look at where I can pull out x cubes by timesing things together over here. I get 0x cubed is equal to, let's see, well, I've got this one times this one, negative 4x cubed. That's going to give me a cubed thing. And then I've got this one times this one, so plus mx cubed. Now, is there any way that this n here is going to combine to give me a cube? No, there's not, because the highest power I'll get there is nx squared. So there are just going to be those two terms. Let's clean that up a bit. So that tells me that 0, looking just at the coefficients now, is equal to negative 4 plus m. So m is equal to 4. So we're going to chuck that in and we're going to keep on going. So maybe just put that into a bubble. That's not very clean, but it will work, right? So p of x is now equal to x squared minus x plus 2 times 4x squared plus 4x plus n plus 4x plus n. So we just have to work out the constant on the end. How can I do that? Well, I still can't really work with this b, the constant, because that would give me b is equal to 2n, which is pretty useless. But I can pick on the 11x now, and I'm going to figure out the x terms. So we have 11x is now going to come from, well, it's not going to come from 4x squared times anything, but if I take the 4x and the 2, that gives me 8x. And if I take the plus n here and the minus x here, that gives me the other x part. Right, so we have 11 equals 8 minus n, giving me n equals negative 3. That means that I'm down to this. P of x is equal to x squared minus x plus 2 times 4x squared plus 4x minus 3. Now, what were we asked to figure out? Well, we started off by saying that P of x was equal to this polynomial, 4x to the power of 4 plus ax squared plus 11x plus b. So we need the coefficient of the x squared term. So ax squared is going to equal the x squared times the negative 3, so negative 3x squared minus 4x squared from here plus 8x squared from in here. Ax squared is equal to what? Well, minus 3 minus 4 plus 8, so that's equal to x squared. That gives me a is equal to 1. Now figuring out b is going to be easier. B is the constant, which will come from only one combination. So we get b is equal to 2 times negative 3, which is negative 6. So we've done that bit. Now I'm going to finish this off now and do the factorising. Then I'm going to come back and show you how to do it by long division. But I think long division is really messy and really easy to make a mistake. So part 2 of this question, just going back up here, was to, once we've found a and b, figure out the real roots of this equation. And this is pretty straightforward now. So p of x is equal to x squared minus x plus 2 times 4x squared plus 4x minus 3. So x squared minus x plus 2 has discriminant of negative 1 squared, b squared minus 4 times 1 times 2, which is negative, so it has no real roots. Now let's take a look at this. I need to factorise this. 4x squared plus 4x minus 3 is equal to, well, let's see if we can do it by inspection. Let's try 2x and 2x. And I want a minus 3 and a plus 4. And you can tell that's going to work because you're going to get a minus 6x somewhere. So let's try minus 3. That gives me minus 6x plus 2x coming in here. So what do we have? Well, we've got p of x, fully factorising, is equal to x squared minus x plus 2 times 2x minus 1 times 2x plus 3. Now notice we were asked for the real roots, not all 4 of the roots. So the real roots are x equals 1/2 and x equals negative 3 over 2. Now for some practice, what you might like to do is assume it had asked you for all 4 roots and go on and solve this equation equal to 0, and you'll of course notice that you get 2 roots from that and they are both complex and one is the conjugate of the other. Right, because the conjugate root theorem tells us that that must happen. With real coefficients, the roots appear in conjugate pairs. Now, let's go back to the long division, and I'll just show you how to do that. Feel free to stop watching at this point. So let's see. If we've got this, how can I do long division? Well, remember that we have to put a column in for the 0x cubed, and then we've got ax squared, yuck, plus 11x plus b. So I need to match this. I'm going to start with 4x squared here. So we get 4x to the power of 4 minus 4x cubed plus 8x squared. Right, put brackets around it and subtract it. What am I left with? Well, I get 4x cubed plus a minus 8 x squared, and then I bring down the 11x. So far so good, not too bad. I'm going to have 4x here. So I guess it is good for getting that bit out quickly. It's just the next bit is going to go a bit messy. So now 4x times all of this is going to give me 4x cubed minus 4x squared plus 8x. Right, subtracting all that, what do I get? Well, I get 0. A minus 8 plus 4. Right, just be careful of this. A minus 8 plus 4 is a minus 4x squared plus 3x plus b. So what do I want to do now? Well, I have to match this. So I've got to have plus a minus 4, giving me a minus 4 here, x squared. See, this is why I don't like it. Minus a minus 4x plus 2 times a minus 4. And I know because this is a factor that all of this has to equal 0. Right? So that leaves me with 0, 3 plus a minus 4x plus b minus 2, a minus 4. So at this point I'm just going, God, there really has to be a better way. And then what I need to reason next is that since x squared minus x plus 2 is a factor, we know that this remainder has got to be 0. And that means that 3 plus a minus 4, which of course is a minus 1, must equal 0. And that generates a equals 1. And now doing the same thing for b. B minus 2 a minus 4 is equal to b minus 2 times 1 minus 4, and so on. So we get b minus 2 times negative 3, so b plus 6, and that has to equal 0 as well, right? Because this whole remainder has got to equal 0, which means that the coefficient on x has got to be 0 and the constant's got to be 0. So we get b equals negative 6, right? So I'm happy to be convinced that doing long division is a good way, but I think I'm going to win that argument. Please let me know if you disagree. That's all for now. I'm going to do a couple more from this assignment tomorrow, especially, I think I'll do the vectors one, and also maybe the binomial theorem one. Thanks for watching.